Hello everyone. So far in this course, we have looked into seismic design and ductile detailing of various building structures including reinforced concrete, steel and masonry buildings. We have looked how their structural elements are designed and detailed for ductility, and we have also illustrated the same through example problems as much as possible. Today, we will start our discussion into seismic safety of non-structural components of a given building. So, the first thing which comes to our mind is that why do we need to study or why do we need to ensure safety of non-structural components in a building. Let us say we have a given building over here, we have plumbing lines. Since we need water supply in the building, we have a small rooftop water tank on the given building. We also have many equipments including washing machines or gas cylinders, etc. We also have some sunshades, etc. placed in the building. We have gas pipeline coming into building. We have the electrical line coming into building, and at the end of the day it was election time in the region, and some politician also put the portrait over here as a hoarding. So, all of these are a lot of non-structural components in the building. So, modern buildings contain a lot of non-structural components, and if you see in modern days we have a lot of non-structural components accounting to more than 90% in case of hospitals and over 80% in case of offices and hotels, and roughly 60% in case of residential buildings, which is still very high. Further, as we have moved in time, these days the cost of non-structural components of a building has risen, and damage to these non-structural components may lead to severe loss of revenue, because there are lots of cost involved related to non-structural components. The functionality of the building is also lost. For example, in case of a hospital building, you have non-structural components such as oxygen gas pipelines, a lot of electrical cables, a lot of pipelines for other gases. Then you also have oxygen cylinders and other facilities of that nature placed in and around the hospital. Now, what happens if such critical pipeline of a hospital fails? Then in the aftermath of disaster, it will be very difficult to keep that hospital functional, and if the hospital loses its functionality, then it is a very serious concern. So, therefore, damage to these non-structural components is very hazardous in that case. The damage to non-structural components can also lead to casualties and injuries to the occupants of the building during the earthquake itself. Then, if there is some gas leakage which catches fire afterwards, so there can be secondary hazards which can be after the earthquake. So, that can lead to more casualties and injuries, more loss of property, etc. Further, the damage to non-structural components can also lead to damage to structural components. How is it possible? If there is a very massive non-structural components such as a rooftop water tank or a very heavy equipment, and if it collapses, then it can lead to damage of the slab or a column nearby and so on. Further, the behavior of building is also influenced by presence of non-structural components. Usually, when your non-structural component is very heavy, then in that case it can change the dynamics of the building, it can change the force demand on the building, it can change the deformation demand on various members of the building. So, based on this pretext, you would have understood that we need to study or ensure safety of non-structural components. In this lecture, we shall also look into classification of these non-structural components. So, the first classification of non-structural components is based on the nature or the functional nature of these components. Now, non-structural components are also sometimes called as architectural elements and utilities. Now, this term is from Indian Standard Code IS 1893 Part 1 and Part 5 2025. So, in this case, the different architectural elements and utilities are classified as building contents, appendages to buildings, and services and utilities. The first category, which is the building contents, include items that are required for enabling the functionality or the use of a spaces. What are such items? For example, furnitures. I am sitting on a chair while delivering this lecture. I have a table in front of me. All of these are very important for ensuring the functionality or use of this very space, which is the recording room. Now, we also need facilities and equipment, which can be refrigerators, washing machines, gas cylinders, false ceiling, etc., depending on what is the functionality of the building. For example, in the hall where I am sitting as of now, we have a lot of electrical equipments as well as lighting equipments. We have camera, we have a screen. So, all of those equipments can be classified as building contents, because these items are required for functionally enabling the use of the space. We also have infill and partition walls. Then we have the frames and panels of doors and windows. So, all of those are building contents. They are not structural elements. Why are they not classified as structural elements? In particular to reinforced concrete or steel buildings, you will find that the infill or partition walls do not carry any load. So, in that case, they cannot be classified as structural element, because failure of these may not lead to the collapse of structure unless it attacks a structural element so badly that the structural element gets damaged. Similarly, the door panels, window panels and frames are also not part of the structural components. Okay, now let us look into the second category of architectural elements and utilities, or the non-structural components, which is called appendages to buildings. These comprise items projecting out of the building or attached to exterior surface. What are the typical examples? We can have architectural facade, which can be in glass or stone cladding. These days we are also having cladding of different types, including fiber cladding and terracotta cladding, etc. A lot of different cladding has come up. Some are being developed for good thermal insulation, while others are for architectural reasons for aesthetic purpose. Then we will have the rooftop water tank. This is also an item projecting out of the building. This is not a structural element in the building. However, if you can consider this very as a structural element in the building, that is in the numerical model, you can analyze the same, then you can classify it as a structural element. You also have parapets, which is a small wall on the rooftop. Then you have the sunshades on your windows. Then you have hoardings, which some buildings have. Then we have antennas also installed on some buildings. So, all of these items are projecting out of the building, and therefore, they are classified as appendages to buildings. Then we have service and utilities. In the services and utilities, we have items which are required for facilitating essential activities in the buildings. Now, these are slightly different from the building contents. In the building content, we need those for functionality of the building, of the space. But for example, if we do not have a chair or table, we cannot use this space for recording lectures. But at the same time, this building can be used for some other purpose, but services and utilities are items that are required for essential activities in the building. This is not for the desired functionality, this is essential activities in the building, such as elevators. We can have plumbing lines, which include water pipes, sewage lines, gas pipelines and rainwater drain pipes. We will have electrical lines, which will include cables, wiring, etc. We will have fire hydrant systems, which shall include water pipes through the buildings. Then we will have telecommunication wires from outside to inside of the building and within the building. Similarly, from outside to inside of the building there shall be electrical lines as well. Then we will have HVAC line, heating, ventilation and air conditioning lines, such as air conditioning ducts, etc. So all of these are required for facilitating essential activities in the building. These are not enabling the functionality of the use of a space. On the other hand, the furniture, equipment, etc. enable functional use of the space. So this is one kind of classification which is based on the nature or the functionality of the non-structural components or the architectural elements and utilities. Now let us classify it in a engineered manner. So what an engineer will think? It will depend on the behavior of these elements. For example, if you have a stiff and massive AEU, I will write architectural elements and utilities as AEU. So this terminology is from IS 1893 2025. So these stiff and massive AEUs will slide or topple, or slide and topple both at the level of their base during ground shaking if they are not anchored properly. So the failure in this case is in terms of sliding or toppling or both of them. These are classified as acceleration sensitive AEUs. Why? Because they usually are sensitive to acceleration of the floor on which they are installed. At the same time, there will be some flexible and long AEU, like we have a chandelier or we have a pipeline which is connected at 2 points of the building. Then in that case, the safety of that pipeline will depend on the structural deformation in the building, that is the displacement between those 2 points. How do those 2 points move with respect to each other? In this case, the deformation sensitive AEUs will move or swing by large amounts in translation and or rotation during ground shaking. Then you have some hybrid AEUs which are called acceleration cum deformation sensitive AEUs or ADAEUs. These are massive AEUs, but they are also long, which means they are flexible as well. So they are flexible, but they have massive weight, which makes them sensitive to both acceleration and deformation. So such AEUs sustain effects which are related to both AEUs and DAEUs. Now let us see these through some examples. These are the examples which I have obtained from IS 1893 2025 and are very well established examples. First of all, we shall look into building contents, then appendages to building, and then services and utilities. Within building contents, we have first subcategory as furniture and equipment. Within furniture and equipment, we have various subcategories as shown over here. So these are classified as acceleration sensitive AEUs. Why? Because these are massive and stiff AEUs. So their stiffness is high, their mass is high, and so on. So they are classified as AAU. I will read out the example so that you can relate to the point which I am making. Cabinets, multi-level storage racks, bookshelves, large sofa sets, large tables, cupboards, wall mountings, these furniture are massive and stiff. At the same time, we have appliances also which are massive and stiff, such as refrigerators, washing machines, gas cylinders, wall and table mounted televisions, diesel generators, water pumps, window air conditioners and wall mounted air conditioners. All of these are stiff and massive. By stiff I mean the acceleration in these appliances shall be almost the same as the acceleration in the wall or floor on which they are mounted. Now let us look into architectural finishes inside the structure which are also part of building contents, such as the doors and windows, the glass panes with frames and other partitions. Now these are classified as ADAEUs, which means they are acceleration cum deformation sensitive AEUs. So they will be classified as primary and secondary. By primary and secondary I mean that these doors and windows are ADAEUs, but primarily they are deformation sensitive and secondary they are also acceleration sensitive. So if you have to classify it in only one category, the primary action is that they are sensitive to the deformation. So they are more of flexible nature. Okay. At the same time, if you look into false ceiling, false ceilings are acceleration sensitive AEUs if they are supported on a secondary system integrated with the ceiling or on the vertical elements of the lateral force resisting system. What does it mean? If your false ceiling is supported on a frame which is integrated with the ceiling or the walls of the building, then in that case that shall be classified as AAEU because that will be acceleration sensitive. So the rigid connection of any non-structural component with the structural members, you can classify it more into AAEU. But if it is directly hung, which is very flexible, then in that case it can be classified as both. The primary action will be deformation sensitive and then acceleration sensitive. Similarly, we have all the staircases and some partitions which are ADAEUs. We have appendages such as tiles and other claddings. So these are AAEUs because they are rigidly connected to the walls. Then we have composite large panels, so this will be ADAEU, and the paintings which are very flexibly connected through one or two screws, then in that case they will be deformation sensitive AEUs. Then let us look further into more architectural finishes inside the structures such as hangings, so chandeliers, then building maintenance unit, restraint system hung from ceilings, then you have huge wall paintings. So all of these can be classified as ADAEUs, but if you have a very small painting, that can be classified as deformation sensitive AEU. Since it is massive now, it is both massive and flexible, it will be ADAEU. Similarly for chandelier also, these days the weight of chandelier is going very high. So you have very heavy chandeliers being placed in different buildings, and in that case it will be classified as both. Small chandeliers may be classified as DAEUs. Then ceiling mounted chandeliers which are directly mounted to the ceiling without a string or rope, in that case it may be classified as AAEUs. So ultimately the classification depends mostly on the experience and judgment of the engineer. Now let us look into equipments in the building content. We can have sensitive equipment such as ventilator, voile separators, bedside monitors, etc. All of these are mostly present in laboratories and hospital buildings. So these are acceleration sensitive non-structural components, which is AAEUs. Why? Because these are massive and stiff equipment placed on the ground. Mostly they are anchored to the ground. We will understand as we proceed through this course why do we anchor them, and so on. We also have a special equipment such as color Doppler or endoscopes, slit lamp with applanation tonometer, X-ray machine, ECG machine, ultrasound machine, oxygen concentrator, automatic cell counter. All of these equipment mostly found in hospitals and laboratories. All of these are acceleration sensitive AEUs. We have generic equipment such as CT scan, centrifuge machine, operating table, and so on, which are again classified as acceleration sensitive AEUs because of their rigid and massive nature. Again, you can look at autoclave over here. Coming to some equipment which are more common to you as civil engineering folks, we can have UTM, universal testing machine. We can have compressive testing machine, CTM. We can have shake tables. All of these equipments shall come under AAUs, that is acceleration sensitive AEUs. Now, once we have looked into building contents, let us look into appendages to buildings. What are appendages to buildings? You might recall these are the projections which are connected to the exterior surface of the building, to the walls, to the roof, etc. So, you can have interior and exterior facade which will include tiles and other cladding including ceramic, stone, glass or any other. You can have all these claddings hung from hooks or something, but they will be rigidly connected to the surface. So, they will be classified as acceleration sensitive AEUs. Then you have composite large panels which can be classified as ADAEU, but again it depends upon the judgment of the engineer how to classify it. We have vertical projections such as chimneys and stacks, parapets, water tanks small, then holdings anchored on rooftops, antennas and communication tower on rooftop. Solar panels these days are getting popular on rooftops and some places on the vertical walls as well because of renewable nature of solar energy. Then bust on standalone stub, then building maintenance unit, restraint system located on rooftops, etc. So, all of these can be classified as acceleration sensitive AEUs because these are stiff and massive in nature. Now, having understood this, let us look into horizontal projections which include sunshades and exterior shading systems, canopies, awnings and marquees, holdings anchored to vertical face. So, all of these are mostly classified as acceleration sensitive AEUs because these are massive elements which are connected to the building. Holdings anchored to the vertical face can be classified as ADAEU depending on flexibility of the system or the connection. Then the exterior structural glazing system of all types shall be classified as ADAEU. Okay. Once we have understood the classification related to appendages of buildings, let us understand about the services and utilities. So, from within and outside to inside of the building, we can have different types of services and utilities such as water supply pipelines, electricity cables and wires, gas pipelines which can include different gas pipelines such as O2, CO2 and other gas pipelines in case of hospitals. We can have drainage sewage pipelines, we will have telecommunication wires, we will have rainwater drain pipes, elevators, fire hydrant systems and the sprinkler systems, air conditioning, fire and the smoke exhaust ducts, etc. Most of these can be classified as DAEUs. Why? Because these are connected to the building at multiple locations. If something is connected at multiple locations, it is highly prone to damage when these points where it is mounted to the structure suffer differential movement. In that case, these AEUs will have to stretch or compress itself, and since these are mostly made up of metal and all which are difficult to do that, then it will suffer some damage. So, most of these can be classified as deformation sensitive AAUs. Now, within the building we can have pipes carrying a specialized fluids, fire hydrants piping system and other fluid piping system. These can be classified as ADAU depending on the judgment of the engineer, but most of these services and utilities can still be classified as DAUs. As you can see, even these have been classified primarily as DAUs. Let us look into some other services and utilities such as storage vessels and water heaters. Now, since these are massive elements such including flat bottomed containers and vessels and structurally supported vessels, these shall be classified as AAUs. We can have mechanical equipment such as boilers and furnaces, then HVAC equipment, etc. Some are even part of the building content. So, these are mostly classified as AAUs, but some of them may be classified as DAUs or combined, that is ADAUs. So, summarizing, in this lecture we have first classified different non-structural components, or we call architectural elements and utilities, into different types, which are building contents, appendages to buildings and services and utilities. Then we have classified these AAUs into three classes in an engineered manner, which are acceleration sensitive, displacement sensitive and acceleration cum displacement sensitive. Which are acceleration sensitive, deformation sensitive and acceleration cum deformation sensitive, that is AAUs, DAUs and ADAUs. Then we have also provided you enough examples to understand what these classifications of AAU, DAU and ADAU matter or meaning to us using different examples. These examples have been obtained from IS 1893 2025. In the next class, we will look into the behavior of non-structural components in a given building. Thank you.